Okay, so for this lecture, it's just going to be nice and easy, some temperature vocabulary, so that way next class we can discuss phase diagrams and have a bit more background information. Okay, so some words that we need to know in terms of phase changes. So first is vaporization. This is the change in state from liquid to gas. So if you've ever left a glass of water out and later came up and it was gone and your cat didn't drink out of it, then it was probably vaporized into the air. Condensation is the change in state from gas to liquid. If you have a cold cup of water and you have a bunch of droplets around on the outside, your glass is not leaking. Water vapor is condensating onto your glass. Melting, this is the change in state from solid to liquid. You leave an ice cube out, it melts into water. That's melting. Freezing, the change in state from liquid to solid. Right, if you put a tray of ice cubes in the freezer, eventually they'll freeze. So the next two are the kind of weirder ones. So sublimation. This is the change in state directly from solid to gas. So we saw this in the lab with, what was it? When we did the what forces it activity last semester. So you should have seen it with dry ice and with iodine. So right, going straight from solid to gas, and deposition is the opposite, so going from gas to a solid. Okay. So this is just another visual of this, right? So liquids are here in the middle, solids, and then gases. So if we're starting with solid, it can either sublime into gas, and then that gas can have deposition back into solid, or we can go from melting to liquid, and then that liquid is going to vaporize to gas. The gas is going to condense into liquid and then freeze back into solid. So there's just kind of the energy changes, and right, if we're going, solid is low energy and gases are very high in energy. So in terms of vapor is kind of a weird thing, and we have this thing called vapor pressure. And so I'm going to start with actually what the definition is, right? So vapor pressure is the pressure of the vapor over the liquid measured at equilibrium at some temperature. And right, this is in dynamic equilibrium, meaning like if we're in a sealed container, it's going to be vaporizing and then condensing, but that vapor is going to create some amount of pressure, and that pressure is vapor pressure, and it's specific to each liquid, each substance. It's measured in this way. Don't stress too much about how it's measured, but what happens is, right, if we have this mercury here, and next unit we'll talk about like what this instrument is, right? So we have mercury and we have some water on top, and what happens is this water, as it comes up, it's going to have some vaporize, right? So we see this happening, and that's going to force the mercury to drop in level in some way, and that drop is the pressure from the water vapor, and that's how we're going to know what the vapor pressure is of water or of another substance. Okay. Temperature, or vapor pressure, is dependent on temperature. So, right, we see here along the y-axis is vapor pressure, and then here's temperature. If we look at water, the for most of these things, right, the vapor pressure is going to increase with the rise in temperature. All that. Right? So there is a difference between vaporization, evaporation, and boiling. So, right, vaporization is the general term. That's changing in state from liquid to gas. Evaporation is when the particles are escaping from the surface of a non-boiling liquid and enter the gas phase. So, right, vaporization is the change. Evaporation is the process. And then boiling is when it's changing from liquid to a vapor, and it's happening within the liquid as well as at the surface. So, right, evaporation we don't really see. It takes a while. Versus boiling, we can see because we see the bubbling within the liquid. Right? So, nice quick lecture on temperature change vocab.